Hello everyone. Question is, you are an ML engineer working for a logistics company that uses multiple machine learning models to optimize delivery routes in real time. Each model needs to process data quickly to provide up to the minute route adjustments. But the company also has strict cost constraints. You need to deploy the models in an environment where performance, cost, and latency are carefully balanced. There may be slight variations in the access frequency of the models. Any excessive cost could impact the project's profitability. Which of the following strategies should you consider to balance the trade-offs between performance, cost, and latency when deploying your model in Amazon SageMaker? Select two options. Option A, choose a lower cost CPU instance accepting longer inference times as the savings on compute cost are more important than minimizing latency. Option B, leverage Amazon SageMaker Neo to compile the model for optimized development on edge devices, reducing latency and cost but with limited scalability for large datasets. Option C, use Amazon SageMaker's multi-model endpoint to deploy multiple models on a single instance, reducing cost by sharing resources. Option D, implement auto-scaling on a fleet of medium-sized instances, allowing the system to adjust resources based on real-time demand, balancing cost and performance dynamically. Option E, deploy the model on a high-performance GPU instance to minimize latency regardless of the highest cost, ensuring real-time route adjustments. Correct answer is option C and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a machine learning engineer at an e-commerce company that uses a recommendation model to suggest products to customers. The model was trained on data from the past year, but after being in production for several months, you notice that the model's recommendations are becoming less relevant. You suspect that either data drift or model drift could be causing the decline in performance. To investigate and resolve the issue, you need to understand the difference between these two types of drift and how to monitor them using Amazon SageMaker. Which of the following statements best describes the difference between data drift and model drift and how you would address them using Amazon SageMaker? Option A, data drift occurs when the distribution of the input data changes over time, while model drift happens when the model's underlying assumptions or parameters becomes outdated. To address data drift, you should use SageMaker Model Monitor to track changes in input data distribution. For model drift, you should periodically retrain the model using the latest data. Option B, data drift is a sudden change in the model's accuracy, while model drift is a gradual degradation in model performance. You should use SageMaker features to manage both types of drift by standardizing input data. Option C, data drift occurs when the model's predictions start to deviate from the expected outcomes, while model drift occurs when the model's accuracy declines due to changes in the input data. SageMaker pipelines should be used to automate retraining for both types of drift. Option D. Data drift refers to changes in the model's accuracy due to shifts in the data, while model drift refers to changes in the underlying data features over time. To address both, you should use SageMaker Clarify to detect bias and retrain the model monthly. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a data scientist at a pharmaceutical company that builds predictive models to analyze clinical trial data. Due to regulatory requirements, the company must maintain strict version control of all models used in decision-making processes. This includes tracking which data, hyperparameters, and code were used to train each model, as well as ensuring that models can be easily reproduced and audited in the future. You decide to implement a system to manage model versions and track their life cycle effectively. Which of the following strategies is the most likely to ensure model versioning, repeatability, and auditability? Option A. Leverage the SageMaker model registry to register, track, and manage different versions of models, capturing all relevant metadata, including data sources, hyperparameters, and training code. Option B. Create a version control system in Git for models training code and configuration files, while storing the trained models in a separate S3 bucket for easy retrieval. Option C. Use Amazon S3 to store each version of the model manually, tagging the stored files with metadata about the training data, hyperparameters, and code used for training. Option D. Use SageMaker Model Monitor to track the performance of models in production, ensuring that any changes in model behavior are documented for future audits. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a machine learning engineer at a financial services company tasked with building a real-time fraud detection system. The model needs to be highly accurate to minimize false positives and false negatives. However, the company has a limited budget for cloud resources and the model needs to be retrained frequently to adapt to new fraud patterns. You must carefully balance model performance, training time, and cost to meet these requirements. Which of the following strategies is the most likely to achieve an optimal balance between model performance, training time, and cost? Option A. Deploy a simpler model like logistic regression to reduce training time and cost, while accepting a slight reduction in model accuracy. Option B. Implement a tree-based model like XGBoost with early stopping and hyperparameter tuning, balancing accuracy with reduced training time and computational cost. Option C. Use a deep neural network with multiple layers and complex architecture to maximize performance even if it requires significant computational resources, and longer training times. Option D, choose a support vector machine SVM with a nonlinear kernel to enhance accuracy regardless of the increased training time and cost associated with large datasets. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are an ML engineer working for a healthcare company that uses a machine learning model to recommend personalized treatment plans to patients. The model is deployed on Amazon SageMaker and is critical to the company's operations, as any incorrect predictions could have significant consequences. A new version of the model has been developed and you need to deploy it in production. However, you want to ensure that the deployment process is robust, allowing you to quickly roll back to the previous version if any issue arises. Additionally, you need to maintain version control for future updates and manage traffic between different model versions. Which of the following strategies should you implement to ensure a smooth and reliable deployment of the new model version using Amazon SageMaker, considering best practices for versioning and rollback strategies? Select two options. Option A, utilize Amazon SageMaker's blue-green deployment strategy to shift traffic gradually from the old model to the new one, ensuring that you can monitor performance and quickly revert if needed. Option B, deploy the new model version immediately and redirect 100% of traffic to it, assuming it has been thoroughly tested and will not require a rollback. Option C, use Amazon SageMaker's built-in versioning to manage different versions of the model and deploy the new version in a canary release by redirecting a small percentage of traffic to it initially. Option D, create a backup of the current model, deploy the new version, and if any issue arises, manually roll back by redeploying the previous model version. Option E, deploy the new model version alongside the current one and use Amazon SageMaker's multi-model endpoint to serve both models simultaneously, splitting traffic between them. Correct answer is option A and option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a data scientist at a marketing agency tasked with creating a sentiment analysis model to analyze customer reviews for a new product. The company wants to quickly deploy a solution with minimal training time and development effort. You decide to leverage a pre-trained natural language processing NLP model and fine-tune it using a custom dataset of labeled customer reviews. Your team has access to both Amazon Bedrock and SageMaker Jumpstart. Which approach is the most appropriate for fine-tuning the pre-trained model with your custom dataset? Option A, use SageMaker Jumpstart to create a custom container for your pre-trained model and manually implement fine-tuning with TensorFlow. Option B, use SageMaker Jumpstart to deploy a pre-trained NLP model and use the built-in fine-tuning functionality with your custom dataset to create a customized sentiment analysis model. Option C, use Amazon Bedrock to train a model from scratch using your custom dataset, as Bedrock is optimized for training large models efficiently. Option D, use Amazon Bedrock to select a foundation model from a third-party provider, then fine-tune the model directly in the Bedrock interface using your custom dataset. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a machine learning engineer at a healthcare company responsible for developing and deploying an end-to-end ML workflow for predicting patient readmission rates. The workflow involves data processing, model training, hyperparameter tuning, and deployment. Additionally, the solution must support regular retraining of the model as new data becomes available with minimal manual intervention. You need to select the right solution to orchestrate this workflow efficiently while ensuring scalability, reliability, and ease of management. Given these requirements, which of the following options is the most suitable for orchestrating your ML workflow? Option A, implement the entire ML workflow using Amazon SageMaker pipelines, which provides integrated orchestration for data processing, model training, tuning, and deployment. Option B, use AWS step functions to define and orchestrate each step of the ML workflow, integrate with SageMaker for model training and deployment, and leverage AWS Lambda for data processing tasks. Option C, leverage Amazon EC2 instances to manually execute each step of the ML workflow. Use Amazon RDS for storing intermediate results and deploy the model using Amazon SageMaker endpoints. Option D, use AWS Glue for data processing, Amazon SageMaker for model training and tuning, and manually deploy the model to an Amazon EC2 instance for inference. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a data scientist at an insurance company developing a machine learning model to predict the likelihood of claims being fraudulent. The company has a strong commitment to fairness and wants to ensure that the model does not disproportionately affect any specific demographic group. You decide to use Amazon SageMaker Clarify to assess potential bias in your model. In particular, you are interested in understanding how the model's predictions differ across demographic groups when conditioned on relevant factors like income level, which could influence the likelihood of fraudulent claims. Given the scenario, which of the following best describes how conditional demographic disparity (CDD) can be used to assess and mitigate bias in your model? Option A, CDD evaluates the disparity in positive prediction rates across demographic groups, conditioned on a specific feature like income to detect bias that may not be apparent when only considering overall outcomes. Option B, CDD measures the difference in average predicted outcomes between demographic groups, helping to identify overall bias without considering other factors. Option C, CDD assesses the proportion of the correctly predicted outcomes for each demographic group, helping to ensure that the model is equally accurate across groups. Option D, CDD focuses on the relationship between feature importance and demographic groups, highlighting whether certain features disproportionately influence predictions for specific groups. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a machine learning engineer at a biotech company developing a custom deep learning model for analyzing genomic data. The model relies on a specific version of TensorFlow with custom Python libraries and dependencies that are not available in the standard SageMaker environments. To ensure compatibility and flexibility, you decide to use the Bring Your Own Container BYOC approach with Amazon SageMaker for both training and inference. Given this scenario, which steps are most important for successfully deploying your custom container with SageMaker, ensuring that it meets the company's requirements? Option A, package the models as a SageMaker compatible file, upload it to Amazon S3, and use a pre-built SageMaker container for training, ensuring that the training job uses the custom environment. Option B, create a Docker container with the required environment, push the container image to Amazon ECR, that is Elastic Container Registry, and use SageMaker's script mode to execute the training script within the container. Option C, build a Docker container with the required TensorFlow version with dependencies. Push the container image to Docker Hub and reference the image in SageMaker when creating the training job. Option D, deploy the model locally using Docker, then use the AWS Management Console to manually copy the environment and model files to a SageMaker instance for training. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a data scientist at a financial technology company developing a fraud detection system. The system needs to identify fraudulent transactions in real time based on patterns in transaction data, including amounts, locations, times, and account histories. The dataset is large and highly imbalanced, with only a small percentage of transactions labeled as fraudulent. Your team has access to Amazon SageMaker and is considering various built-in algorithms to build the model. Given the need for both high accuracy and the ability to handle imbalanced data, which SageMaker built-in algorithm is the most suitable for this use case? Option A. Implement the k-nearest neighbors (KNN) algorithm to classify transactions based on similarity to known fraudulent cases. Option B. Apply the XGBoost algorithm with a custom objective function to optimize for precision and recall. Option C. Select the random cut forest RCF algorithm for its ability to detect anomalies in transaction data. Option D. Use the linear learner algorithm with weighted classification to address the case imbalance. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a machine learning engineer at a fintech company tasked with developing and deploying an end-to-end machine learning workflow for fraud detection. The workflow involves multiple steps including data extraction, pre-processing, feature engineering, model training, hyperparameter tuning, and deployment. The company requires the solutions to be scalable, support complex dependencies between tasks, and provide robust monitoring and versioning capabilities. Additionally, the workflow needs to integrate seamlessly with existing AWS services. Which deployment orchestrator is the most suitable for managing and automating your ML workflow? Option A. Use AWS step functions to build a serverless workflow that integrates with SageMaker for model training and deployment, ensuring scalability and fault tolerance. Option B. Use AWS Lambda functions to manually trigger each step of the ML workflow, enabling flexible execution without needing a predefined orchestration tool. Option C. Use Amazon SageMaker pipelines to orchestrate the entire ML workflow, leveraging its built-in integration with SageMaker features like training, tuning, and deployment. Option D. Use Apache Airflow to define and manage the workflow with custom DAGs, that is, directed acyclic graphs, integrating with AWS services through operators and hooks. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are tasked with building a predictive model for customer lifetime value (CLV) using Amazon SageMaker. Given the complexity of the model, it is crucial to optimize hyperparameters to achieve the best possible performance. You decide to use SageMaker's automatic model tuning, that is hyperparameter optimization, with random search strategy to fine-tune the model. You have a large data set and the tuning job involves several hyperparameters including the learning rate, batch size, and dropout rate. During the tuning process, you observe that some of the trials are not converging effectively and the results are not as expected. You suspect that the hyperparameter ranges or the strategy you are using may need adjustment. Which of the following approaches is most likely to improve the effectiveness of the hyperparameter tuning process? Option A, increase the number of total trials but increase the number of parallel jobs to speed up the tuning process. Option B, switch from the random search strategy to the Bayesian optimization strategy and narrow the range of critical hyperparameter. Option C, use the grid search strategy with a wide range for all hyperparameters and increase the number of total trials. Option D, increase the number of hyperparameters being tuned and widen the range for all hyperparameters. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company stores its training datasets on Amazon S3 in the form of tabular data running into millions of rows. The company needs to prepare this data for machine learning jobs. The data preparation involves data selection, cleansing, exploration, and visualization using a single visual interface. Which Amazon SageMaker service is the best fit for this requirement? Option A, Amazon SageMaker Feature Store. Option B, Amazon SageMaker Data Wrangler. Option C, SageMaker Model Dashboard. Option D, Amazon SageMaker Clarify. Correct answer is option B. Question is, which of the following strategies best aligns with the defense in-depth security approach for generative AI applications on AWS? Option A, relying solely on data encryption to protect the AI training data. Option B, applying multiple layers of security measures including input validation, access controls, and continuous monitoring to address vulnerabilities. Option C, using a single authentication mechanism for all users and services accessing the AI models. Option D, implementing a single layer firewall to block unauthorized access to the AI models. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are an ML engineer at an e-commerce company tasked with building an automated recommendation system that scales during peak shopping seasons. The solution requires provisioning multiple compute resources including SageMaker for model training, EC2 instances for data preprocessing, and an RDS database for storing user interaction data. You need to automate the deployment and management of these resources, ensuring that the stacks can communicate effectively. The company prioritizes infrastructure as code IAC to maintain consistency and scalability across environments. Which approach is the most suitable for automating the provisioning of compute resources and ensuring seamless communication between stacks? Option A manually provision the SageMaker EC2 and RDS resources using the AWS Management Console, ensuring that communication is established by manually updating security groups and networking configurations. Option B use AWS Elastic Beanstalk to deploy the entire ML solution, relying on its built-in environment management to handle the provisioning and communication between resources automatically. Option C use AWS CDK, that is Cloud Development Kit, to define the infrastructure in a high-level programming language, deploying each service as an independent stack without configuring inter-stack communication. Option D use AWS CloudFormation with nested stacks to automate the provisioning of SageMaker, EC2, and RDS resources, and configure outputs from one stack as inputs to another to enable communication between them. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a data scientist at a healthcare startup tasked with developing a machine learning model to predict the likelihood of patients developing a specific chronic disease within the next 5 years. The dataset is available includes patient demographics, medical history, lab results, and lifestyle factors, but it is relatively small with only 1,000 records. Additionally, the dataset has missing values in some critical features, and the class distribution is highly imbalanced with only 5% of patients labeled as having developed the disease. Given the data limitations and the complexity of the problem, which of the following approaches is the most likely to determine the feasibility of an ML solution and guide your next steps? Option A proceed with training a deep neural network DNN model using the available data, as DNNs can handle small datasets by learning complex patterns. Option B increase the dataset size by generating synthetic data and then train a simple logistic regression model to avoid overfitting. Option C conduct exploratory data analysis EDA to understand the data distribution, address missing values, and assess the class imbalance before determining if an ML solution is feasible. Option D immediately apply an oversampling technique to balance the dataset, then train an XGBoost model to maximize performance on the minority class. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a lead machine learning engineer at a growing tech startup that is developing a recommendation system for a mobile app. The recommendation engine must be able to scale quickly as the user base grows, remain cost effective to align with the startup's budget constraints, and be easy to maintain by a small team of engineers. The company has decided to use AWS for the ML infrastructure. Your goal is to design an infrastructure that meets these needs, ensuring that it can handle rapid scaling, remains within budget, and is simple to update and monitor. Which combination of practices and AWS services is most likely to result in a maintainable, scalable, and cost effective ML infrastructure? Option A, implement Amazon SageMaker for model training. Deploy the models using Amazon EC2 with manual scaling to handle inference, and use AWS CloudFormation for managing infrastructure as code to ensure repeatability. Option B, use Amazon SageMaker for both training and deployment. Leverage auto-scaling endpoints for real-time inference and apply SageMaker pipelines for orchestrating end-to-end ML workflows, ensuring scalability and automation. Option C, use Amazon SageMaker for training. Deploy models on Amazon ECS for flexible scaling and implement infrastructure monitoring with a combination of CloudWatch and AWS Systems Manager to ensure maintainability. Option D, train models using Amazon EMR for cost efficiency. Deploy the models using AWS Lambda for serverless inference and manually monitor the system using CloudWatch to reduce operational overhead. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are working as a machine learning engineer for a startup that provides image recognition services. The service is currently in its beta phase and the company expects varying level of traffic, with some days having very few requests and other days experiencing sudden spikes. The company wants to minimize costs during low traffic periods while still being able to handle large infrequent spikes of requests efficiently. Given these requirements, you are considering using Amazon SageMaker for your deployment. Which of the following statements is the best recommendation of the given scenario? Option A, use Amazon SageMaker asynchronous inference that minimizes cost during low traffic periods while managing large infrequent spikes of requests efficiently. Option B, use batch transform to run inference with Amazon SageMaker that minimizes cost during low traffic periods while managing large infrequent spikes of requests efficiently. Option C, use Amazon SageMaker serverless inference that minimizes cost during low traffic periods while managing large infrequent spikes of requests efficiently. Option D, use Amazon SageMaker real-time inference that minimizes cost during low traffic periods while managing large infrequent spikes of requests efficiently. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, which benefits might persuade a developer to choose a transparent and explainable machine learning model? Select two options. Option A, they foster trust and confidence in model predictions. Option B, they enhance security by concealing model logic. Option C, they simplify the integration process with other systems. Option D, they facilitate easier debugging and optimization. Option E, they require less computational power and storage. Correct answer is option A and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are an ML engineer at a data analytics company tasked with training a deep learning model on a large computationally intensive dataset. The training job can tolerate interruptions and is expected to run for several hours or even days, depending on the available compute resources. The company has a limited budget for cloud infrastructure, so you need to minimize cost as much as possible. Which strategy is the most effective for your email training job while minimizing cost and ensuring the job completes successfully? Option A, start the training job using only Spot instances to minimize cost, and switch to on-demand instances manually if any Spot instances are interrupted during training. Option B, use Amazon SageMaker managed Spot training to dynamically allocate Spot instances for the training job, automatically retrying any interrupted instances via checkpoints. Option C, deploy the training job on a fixed number of on-demand EC2 instances to ensure stability and manually add Spot instances as needed to speed up the job during off-peak hours. Option D, use Amazon EC2 auto-scaling to automatically add Spot instances to the training job based on demand and configure the job to continue processing even if some Spot instances are interrupted. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a data scientist working on a deep learning model to classify medical images for disease detection. The model initially shows high accuracy on the training data but performs poorly on the validation set, indicating signs of overfitting. The dataset is limited in size and the model is complex with many parameters. To improve generalization and reduce overfitting, you need to implement appropriate techniques while balancing model complexity and performance. Given these challenges, which combination of techniques is most likely to help prevent overfitting and improve the model's performance on unseen data? Option A, prune the model by removing less important layers and nodes, and use L2 regularization to reduce the magnitude of the model's weights, preventing overfitting. Option B, use assembling by combining multiple versions of the same model trained with different random seeds and apply data augmentation to artificially increase the size of the data set. Option C, combine data augmentation to increase the diversity of the training data with early stopping to prevent overfitting and use assembling to average predictions from multiple models. Option D, apply early stopping to halt training when the validation loss stops improving and use dropout as a regularization technique to prevent the model from becoming too reliant on specific neurons. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has recently migrated to AWS cloud and it wants to optimize the hardware used for its AI workflows. Which of the following would you suggest? Option A, leverage either AWS Trinium or AWS Inferentia for the deep learning DL and generative AI inference applications. Option B, leverage AWS Trinium for high performance, cost effective deep learning training. Leverage AWS Inferentia for the deep learning DL and generative AI inference applications. Option C, leverage either AWS Trinium or AWS Inferentia for high-performance, cost-effective deep learning training. Option D, leverage AWS Inferentia for high-performance, cost-effective deep learning training. Leverage AWS Trinium for the deep learning DL and generative AI inference applications. Correct answer is option B. Question is, your data science team is working on developing a machine learning model to predict customer churn. The dataset that you are using contains hundreds of features, but you suspect that not all of these features are equally important for the model's accuracy. To improve the model's performance and reduce its complexity, the team wants to focus on selecting only the most relevant features that contribute significantly to minimize the model's error rate. Which feature engineering process should your team apply to select a subset of features that are the most relevant towards minimizing the error rate of the trained model? Option A, feature extraction. Option B, feature creation. Option C, feature transformation. Option D, feature selection. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a machine learning engineer managing an ML model deployed on Amazon SageMaker to provide real-time predictions for a financial application. The model is critical for fraud detection and must operate with high availability and low latency. Recently, users have reported increased latency in receiving predictions and there have been occasional timeout errors. To maintain the performance and reliability of the model, you need to configure monitoring and alerting tools to troubleshoot and resolve these issues promptly. Which of the following approaches is the most effective for configuring and using Amazon CloudWatch tools to troubleshoot and analyze the performance of your ML? Solution. Option A. Enable Amazon CloudWatch logs to capture detailed logs from the SageMaker endpoint. Configure CloudWatch alarms to monitor invocation latency and error rates, and set up notifications to alert the team when thresholds are breached. Option B. Use CloudWatch logs insights to manually search and analyze logs from the SageMaker training jobs, and configure CloudWatch alarms to track CPU and memory uses on the EC2 instances running the model. Option C. Enable Amazon CloudTrail for logging all API calls and use CloudWatch logs to monitor network traffic. Create CloudWatch alarm based on API activity to detect performance issues. Option D. Rely on the SageMaker consoles to monitor model performance metrics, and configure CloudWatch logs to store training logs without setting up specific alarms, analyzing logs only when issues arise. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a machine learning engineer responsible for optimizing the cost and performance of an ML model deployed on Amazon SageMaker. The model serves real-time predictions for an e-commerce platform, and the current instance type is providing reliable performance but at a higher cost than anticipated. Your goal is to determine the most cost-effective instance type that still meets the performance requirements for low latency predictions. Which approach is the most effective for right-sizing the instance family and size for your SageMaker endpoint? Option A. Use SageMaker Inference Recommender to run load tests across various instance types and configurations. Compare the performance and cost of each and select the instance type that offers the best balance between cost and performance. Option B. Manually review the performance metrics from Amazon CloudWatch for the current instance and experiment with different instance types by redeploying the model on each until you find the optimal one. Option C. Use AWS Compute Optimizer to analyze the current instance's CPU and memory uses, and automatically switch to the smallest recommended instance type that matches the utilization metrics. Option D. Use SageMaker Inference Recommender to select the lowest cost instance type, regardless of performance, and configure auto-scaling to handle any additional load during peak times. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, which of the following is correct regarding the techniques used to improve the performance of a foundation model FM? Option A. Neither fine-tuning nor retrieval augmented generation RAG changes the weights of the FM. Option B. Both fine-tuning and retrieval augmented generation RAG change the weights of the FM. Option C. Fine-tuning does not change the weights of the FM, whereas retrieval augmented generation RAG changes the weights of the FM. Option D, fine-tuning changes the weights of the FM, whereas retrieval augmented generation RAG does not change the weights of the FM. Correct answer is option D. Question is, you are a data scientist working on a predictive maintenance model for an industrial manufacturing company. The model is designed to predict equipment failures based on sensor data collected over time. During the development process, you notice that the model performs exceptionally well on the training data but struggles to generalize to new unseen data. Additionally, there are some indications that the model might not be fully capturing the complexity of the problem. To ensure the model performs well in production, you need to identify whether it is overfitting, underfitting, or both. Which of the following strategies is the most effective for identifying overfitting and underfitting in your model? Option A, perform cross-validation with different subsets of the data. If the model's performance varies significantly across folds, the model is underfitting. Option B, compare the training and validation loss curves over time. If the validation loss is much higher than the training loss, the model is likely overfitting. Option C, reduce the number of features in the model. If performance improves, the model was previously overfitting. Option D, analyze the model's performance on a separate test set. If the model performs well on both the training and test sets, it is neither overfitting nor underfitting. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, you are a data scientist working for a retail company and you have been tasked with developing a demand forecasting model using Amazon SageMaker. The company requires the model to be highly accurate to optimize inventory levels, but you also need to consider constraints on training time and cost due to budget limitations. You have access to multiple SageMaker instance types and options like spot instances to reduce cost, but you must balance these factors against the need for a performant model. Your goal is to choose a configuration that provides an acceptable trade-off between model performance, training time, and cost. Which of the following strategies should you consider when balancing model performance, training time, and cost in this scenario using Amazon SageMaker? Select two options. Option A, implement distributed training across multiple smaller instances to balance training time and cost while maintaining model performance. Option B, deploy multiple models with different instance types simultaneously, choosing the one that completes training first, regardless of performance or cost. Option C, optimize hyperparameters using Amazon SageMaker's automatic model tuning, that is hyperparameter optimization, to improve performance while using spot instances to reduce cost. Option D, use a smaller instance type to save on costs and accept longer training times as model accuracy is not the highest priority. Option E, use the largest available instance type to minimize training time regardless of cost, ensuring that the model is trained as quickly as possible. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a DevOps engineer responsible for maintaining a serverless machine learning application that provides real-time predictions using AWS Lambda. Recently, users have reported increased latency when interacting with the application, especially during peak usage hours. You need to quickly identify the root cause of the latency and resolve the performance issues to ensure the application remains responsive. Which combination of monitoring and observability tools is the most effective for troubleshooting the latency and performance issues in this serverless application? Option A, use AWS X-Ray to trace requests across the entire application, identify bottlenecks, and visualize the end-to-end latency for each request. Combine this with Amazon CloudWatch Lambda Insights to monitor the Lambda function's memory uses, CPU uses, and invocation times. Option B, use Amazon CloudWatch alarms to set thresholds for Lambda duration and error rates, and configure AWS X-Ray to periodically sample traces from the application for analysis. Option C, enable detailed monitoring in Amazon CloudWatch to track Lambda invocations, errors, and throttles, and manually inspect the Lambda code to identify performance bottlenecks. Option D, deploy Amazon CloudWatch Logs Insights to query and analyze the application logs for errors, and use AWS Config to review recent changes to the infrastructure that might have introduced latency. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a data science team is working on a machine learning project that requires them to ingest large volumes of raw data for analysis and feature engineering. The team plans to use Amazon SageMaker for the project, and they need to efficiently ingest the data into a platform where they can perform transformations and store features for future model training. Which of the following approaches is the most efficient for ingestion data, performing data transformations, and then storing the engineered features? Option A, load the data into an Amazon RDS database, then use SageMaker Clarify to ingest and transform the data for storing in the feature store. Option B, ingest the data into Amazon SageMaker Data Wrangler, perform transformations, and then store the transformed data in SageMaker Feature Store. Option C, ingest the data into AWS Glue for transformations, then store the transformed data in Amazon S3 and load it into Amazon SageMaker using the AWS SDK for Python. Option D, use Amazon S3 to store the raw data, then directly connect SageMaker Feature Store to ingest and transform the data. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, you are a machine learning engineer at a biotechnology company working on a deep learning model to analyze genomic sequences. The model requires significant computational resources for training due to the complexity and size of the dataset, which consists of billions of nucleotide nucleotide sequences. Additionally, once deployed, the model must provide real-time inferences for clinical applications requiring low latency predictions. Your task is to choose the appropriate compute environment for both training and inference. Which of the following compute environment configurations is the most suitable for meeting the training and inference requirements of this use case? Option A, use Amazon SageMaker with P3 instances NVIDIA V100 GPUs for training and deploy the model using ML.M5. Large instances, that is Intel Skylake CPUs for real-time inference to balance cost and performance. Option B, use Amazon EC2 with G4DN instances NVIDIA T4 GPUs for both training and inference, optimizing for cost efficiency while maintaining moderate GPU performance. Option C, use Amazon SageMaker with ML.C5. Large instances Intel Cascade Lake CPUs for training and inference, relying on the CPU's high memory bandwidth for both tasks. Option D, use Amazon SageMaker with P4D instances NVIDIA A100 GPUs for training to handle large-scale deep learning workloads and deploy the model using ML.INF1 instances AWS Inferencia chips for low latency inference. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, what is uncertainty in the context of machine learning? Option A, the clarity of the model's decision-making process. Option B, the speed of the algorithm. Option C, the amount of data available for training. Option D, an imperfect outcome. Correct answer is option D. Question is, a machine learning specialist is developing a proof of concept for government users whose primary concern is security. The specialist is using Amazon SageMaker to train a convolutional neural network CNN model for a photo classifier application. The specialist wants to protect the data so that it cannot be accessed and transferred to a remote host by malicious code accidentally installed on the training container. Which action will provide the most secure protection? Option A, encrypt the weights of the CNN model. Option B, enable network isolation for training jobs. Option C, remove Amazon S3 access permissions from the SageMaker execution rule. Option D, encrypt the training and validation dataset. Correct answer is option B. Question is, a data scientist needs to identify fraudulent user accounts for a company's e-commerce platform. The company wants the ability to determine if a newly created account is associated with a previously known fraudulent user. The data scientist is using AWS Glue to cleanse the company's application logs during ingestion. Which strategy will allow the data scientist to identify fraudulent accounts? Option A, create a find matches machine learning transform in AWS Glue. Option B, run the built-in find duplicates Amazon Athena query. Option C, create an AWS Glue crawler to infer duplicate accounts in the source data. Option D, search for duplicate accounts in the AWS Glue data catalog. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a machine learning specialist is preparing data for training on Amazon SageMaker. The specialist is using one of the SageMaker built-in algorithms for the training. The dataset is stored in .csv format and is transformed into a numpy.array, which appears to be negatively affecting the speed of the training. What should the specialist do to optimize the data for training on SageMaker? Option A, use AWS Glue to compress the data into the Apache Parquet format. Option B, use the SageMaker hyperparameter optimization feature to automatically optimize the data. Option C, transform the dataset into the record IO protobuf format. Option D, use the SageMaker batch transform feature to transform the training data into a data frame. Correct answer is option C. Question is, when is unexplainability not acceptable? Option A, when determining the result of a sports match. Option B, when making product recommendations. Option C, when explaining why a loan was declined. Option D, when explaining why a transaction was deemed fraudulent. Correct answer is option C and option D. Question is, what characterizes a simple machine learning model? Option A, low accuracy but high explainability. Option B, high accuracy and high explainability. Option C, low accuracy and low explainability. Option D, high accuracy but low explainability. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, which solution will meet these requirements? Option A, use the SageMaker feature store getRecord API with the record identifier. Option B, use the SageMaker feature store batch getRecord API with record identifier filter to find the latest record. Option C, create an Amazon Athena query to retrieve the data from the feature table. Use the right underscore table value to find the latest record. Option D, create an Amazon Athena query to retrieve the data from the feature table. Correct answer is option A. Question is, why is it important to estimate the amount of uncertainty in an ML model? Option A, to improve the model's computational efficiency. Option B, to increase the speed of data processing. Option C, to reduce the amount of training data needed. Option D, to avoid potential misinterpretations of life and property. Correct answer is option D. Question is, how is machine learning utilized in healthcare? Option A, automating the patient's check-in process. Option B, managing medical staff schedules. Option C, suggesting treatment for patients by analyzing clinical data. Option B. Scheduling patient appointments. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.